All right, we are live.
All right.
Awesome. So I'll do a brief intro. Hi, everyone. Thanks for joining this session. I'm very excited to host Srihari. He's currently analytics team lead at Claim Genius. One thing I really found unique about his, like, he came from an architecture background. He graduated in 2017 and did his PGP in big data analytics, and his Medium articles are quite amazing. So I thought, why not we can organize this session and share his journey and insights about his work with everyone. So, and he was quite supportive about it, and we are here now. So thanks a lot, Srihari, for your time to do this.
Thank you. Thanks, Manu, for having me. It's great, and I'm glad to be part of this great series that we're going to put up. So yeah, I'm excited.
Okay. The structure is Srihari will be presenting his work, and which is published on Medium articles. So first we'll go through those work, and if you have Q&A, you can type it in the chat and I'll ask those questions.
Cool. Let's get started. So I'll be presenting some of my work in terms of Medium articles that I've put up, and then so I've been working on these exploring different technologies, be it in big data analytics or data science and AI, especially since the inception of these cutting edge technologies that have been coming into all these industries. Architecture is like different. Like there are a lot of things that are happening globally. I thought, like, why not explore different technologies and so basically, when I thought of pursuing this data science, it was not very clear for me like how data can be used. We all speak about a lot of these BIM softwares and a lot of data putting coming in into the system. And also it was a very narrow channel of only focusing on, let us say, environmental design, where you deal with all these environmental variables to kind of design certain buildings. That was basically it when I just started it. But actually, data science can also be used in decision making, which is like a very major part of any creative project, like especially in architecture and urban sciences, urban design. You have to be very specific about, and you need to back that with the data and facts. So the way I started this is basically, I will just go through a simple article that I started initially. So this is a small attempt to understand basically the effect of traffic scenario. Basically, Hyderabad Metro. Basically this was a project that was initiated, and it took quite some time to get realized and operational. So basically, I just tried to analyze. What is the effect of this metro work on the city? Like, did it actually help the city in terms of the lessening the traffic burden, or during the construction period was there any? So the way I did this basically is I just collected some data of Uber movement. This was a data set that kind of they open sourced Uber data open source, like in major cities like Hyderabad, Bangalore. At the time when I started this back in 2018-19. So I just wanted to see if there's any correlation in terms of the overall traffic. I just took this small data set and tried to explore if that can be correlated to any of the global city level scenarios. So basically, Uber movement, they have basically open source some of these data, which they've been tracking it from their Uber rides, based on like the total traffic that happens, and it's a consolidated data set of a certain time frame. And basically I started exploring this data sets. So I just took a simple scenario of two different destinations, like the inception starting of a metro line in a particular city, and then the ending part, which is here. This is Hyderabad scenario. uh, Basically, it's a 35-kilometer long stretch, and I've taken this data of Uber movement data sets, where starting from so basically this got operational in December 2017, right? I've taken different time frames just to analyze what was the scenario before this, during this, and after this, just to get a sense of is there any difference, so that I could correlate that in terms of the traffic. So what I've taken is basically the Q4 data range of 2016, 17, and 18. So 17 is where this all things started, and 2016 is pre metro, and 2018 is post metro. So in order to understand the difference, I need to have that range, so that only like analyzing 2017 data doesn't make any sense, because we need to understand what was the scenario before and after to clearly see the difference. So uh, the way I just did it is like I just downloaded this data 2016 Q4 17 and 18, and it's a simple exercise of just manipulating the data within using Python. And basically it had different basically what it kind of denoted is basically the time taken for a trip to end from a starting point to an end point, based on the different watts that has been divided inside this. What it essentially gives us is basically the average time that is taken for a cab, let us say a trip to complete from destination A to B within the city. It's not a single data wherein like you're talking about multiple trips together, and if everything is consolidated over an average. Like Uber being like a multi there's a lot of at least 100 trips happening every hour within the certain track that we take. So the average would actually give us a complete understanding of the total traffic scenario. That is the reason why they've even released this, in order to help these urban designers and city planners to take and leverage this data and use it in their designing part. So so this is what I did. I just took the data, travel time data for all the 3 years in the Q4, and then basically just did some manipulation. And what I tried to find out is basically the so this final this infographic kind of sums it of everything. uh, so if you look at this, the red line talks about 2016, which was pre-metro. 2017 is during the metro, and 2018 is after that. So if you look at this basic time plot, and this the y-axis talks about the time in minutes. Basically, I've plotted the time taken in terms of trips, average trips, versus the total hour of the day. Basically, during of course like the office hours, and especially during the evening times when the traffic is in the peak, that's when you expect the graph to be up, right? And this talks about if you look at these, there's a slight difference that you can make out, especially after post metro, the travel time kind of decreased, which basically means the the travel scenario, or the this thing has been eased out, especially with the inception of metro, wherein like now it's like a two layer traffic, wherein like people start using metro in order to do that usual communication, daily communication community. And then basically during this final the trips, the basic the carriageway and roads freed up, and that kind of reduced the final travel times in terms of that. So this graph basically just simple data analysis, which will actually help us understand the traffic situation, and try to give some insights in terms of how the data could be leveraged in understanding all this stuff. So this is simply a very small exercise that I did. I just tried to put this up, and basically this kind of helped me to understand a lot of insights from this.
I see. I was just thinking, like, because even when I was leaving, there is metro construction in Mumbai, and that increased the traffic. So I'm just curious. So looked like even like during the metro construction, the travel time decreased, and I was expecting maybe because of the construction there would be more traffic. So it might be possible that the people might have routed on another route, because on the Google map you showed there are like two ways to reach that destination. So maybe on the other destination there would be increment in traffic or duration time.
Yes, right. So that's the reason why I just took the average time, just to in order to account for all those things. Basically, there's a lot of possibilities, right? Like the major. So this actually the use case that I've taken, this Nagar to Miyapur. This is the main road, which is like dissecting through the city. It's very like it's a highway, I would say. basically wherein like all of these internal link routes would actually again converge here in order to kind of make that complete line as a transit line. So there's a possibility, but if you actually take a look at the average time commute based on all these different cases of Uber Transit, what it ultimately gives us is like an average time, which is actually representing the reality as close as possible. And yeah, there's a lot of other things as well. Like this is a very simple naive experiment that I did, but actually using this technology and basically trying to you look at the data objectively will actually help us kind of address all these challenges that we have in terms of the unpredictability and it's basically the nature of the city wherein you cannot predict it. It's not a simple A to B travel system kind of a problem, right? It's a lot of other attributes coming into place and all that. But yeah, I agree that there could be a lot of things that could be done, which kind of the basic model can be built in order to understand like what is the actual effect of that metro.
Yeah, and I think it's a super interesting work because you, based on this data, you could justify that the city, the decision they made, this is how much exactly the time difference it was converted. It's not subjective that okay, make a matter, hopefully it will decrease the commute time. It, you can quantify. And I'm just thinking like if like to take it to next level, suppose I want to propose a new metro in location B. Are you thinking that we can have like similar regression or stats data on many metros, and then we can do prediction that okay, if we build this in future, this is most probably the reduction.
Yeah, yeah, it's quite possible, right? Like we knowing this, as a model which kind of worked for a certain city or which didn't work for a certain city, we could kind of consider those attributes, and yes, the regression can definitely be built up. I don't see any challenge in that. But only thing is like we need to make it more robust so that we do not add unnecessary noise. Basically, again, as an urban designer, it's important to understand that each city conditions are different. You cannot generalize it, but yeah, considering different factors, at least we could get an initial estimate of how things might be in basic. It's for decision making, so definitely all that regressions would help us to take that decision. So that is what data-driven decisions would actually play an important role while having these kind of decisions made.
I see. And is there any like uh, any platform or interface you came across which helps urban designer to make such data driven decision making? I haven't come across. I just wanted to know.
Uh, so there are a lot of things happening. Basically, I can show you a simple tool. I was just exploring this proving grounds app. Like I'm sure you guys must have gone through this. Basically, it's the proving ground is like a very interesting set of tools they're coming up with. That's Miller
Mhm.
and the team. It actually helps us bridge that gap between the VM like Rhino Revit, which can then be like used within Power BI, which is like a very popular and powerful analytics tool. So if you look at these guys, the work they're doing, it's basically they're trying to initialize like a simple conceptual model and then try to see all the different possibilities in terms of iterations. And this is where the decision, the data driven decisions could happen. And essentially they're trying to market this as business intelligence tool for architects separately. So there are a lot of possibilities, like when like all these structural things can be then taken care of. And also at a urban level wherein like we can simulate certain things and try to see if like the environmental aspects, be it like traffic or anything related to city, that can also be simulated and try to be conceptualized. It works both way. Like it works basically during the pre-design process to initially start a particular project, and also post design wherein like you see the effect of it on into its surroundings and environment. So this is interesting stuff that is happening.
I see. Yeah, I think this is a really good company, and they're pushing the boundary in terms of business intelligence in BIM
Yeah.
workflow. Yeah, interesting. Yeah, that's a really good. I really like how you use the Uber data to make like a solution which can be used for urban planners and city planners.
Okay, so I'll just basically go through another piece that I've written lately. It's basically talking about generative design and metric space analysis. This is basically an interesting experiment which has already been there. Like I've just mimicked existing piece of multi-objective genetic algorithm, which basically lets us explore different configurations of a particular design, and we could select an optimum high performing piece, and then we can just conceptualize and build on top of that particular configuration. So it's been there, like we've like genetic algorithms have like a huge history of they've been using these things for a lot of business problems, be it like logistics or supply chain and all that. But in design, I see that it has been like slowly starting getting the traction of especially when Autodesk have started using these kind of basic configurations, wherein like you can just iterate a lot of hundreds of different of configurations, leveraging the computation that we have as part of the recent advancements that they've made in terms of deep learning and all that. So this use case basically talks about a simple prototype that I've built in space planning. So what I started with is like a simple random plot, and just I'm trying to kind of come up with a configuration which kind is like optimized for certain objectives. So simply like trying to configure and optimize it for a single objective is very simple. Like let us say if you want a central land to be, so this basically piece is basically considered to be a neighborhood, and what I'm trying to do here is basically simple green spaces that is I need to like kind of put in terms of maximizing the area, and it also needs to be centralized so that every boundary will be having a equal kind of approach towards this. So that was two different objectives that I tried to optimize this basic configuration on. Uh, the way I started this is basically just like a simple CAD plot of the entire boundary. It's just a random prototype that I've taken, and so the generative design helps us to integrate and kind of iterate different configurations at real time, and we could actually see the effects and it's basically metrics, right? Numbers. So we can actually see what is the configuration of a particular design when it started, and then we could see that progress of how optimized these configurations could get when it comes to the towards the end. That's the advantage of generative design, whereas parametric is basically we've been all trying to do this parametric design wherein you just start with a module and just increase it and in terms of parameterize each and every aspect of it. But generative design is going aggressive in terms of exploring different. Generative design can also take leverage of parametric design, wherein like if you build a parametric model and then you can just run it and simulate it in a particular environment where you run these different configurations and see all the different aspects of how your essential metric is being affected. So this is just basically about that introduction of generative process. And so what is important here is like to come up with these performance metrics. In the case of what I try to do, I'll basically so this is basically like I told simplicity block, wherein I just try to uh, plan it in terms of commercial block and simple green space network, wherein like I wanted to keep a certain percentage of this entire block to be open and green, but also the challenges were to plan the approach, and then there are a lot of metrics that I could come up with. Let us say what the distance between these one of these should be maximized so that you don't end up having everything inside a certain core, so that it will be democratization of like all of them will have the access. and also you need to make sure that it's not like too far from any particular corner, being that kind of affects the travel time and distance. So it's basically an optimization problem. So basically the way I did this, basically using Rhino, I could just I could just uh, simulate this and kind of parameterizes all these simple blocks, and this is a simple road network that I tried to build in. And this entire setup, first I just started with a simple Galapagos. So I've taken certain parametrics here, right? Like first is commercial plots, one is the buzz, like it should be it should not create that congestion in terms of the traffic and everything. So the way to that do that is basically increase the distance between these nodes. That could be a simple metric, right? And then the spread, like the total distance between each of the centers would again matter. So I try to maximize that particular part. Road area, so the area between these basic lines, if that could be maximized, then the circulation area is again in turn will be kind of optimized. So these are some of the metrics that I started with. And using Galapagos, as we all know, it's a being built tool within Rhino, wherein it will help us do this evolutionary solvers by iterating different things. So I just started with this, and this is not like a multi-objective solver. Basically, it does the basic stuff of iterating different things, but uh, uh, basically it would not optimize it for multiple problems. So all I could do it was basically give us certain things for maximizing the area between different configurations, or basically trying to add up these distances. All that mathematical stuff was possible, but it kind of did not give me a complete hand of how to plug in all these different metrics together as a solver, and then I tried multiple times. So now coming to this multi-objective generative algorithm is basically already an existing piece of thing that has been being practiced a lot of in different industries, as I told, like be it logistics or supply chain optimization. But as in design, like it was, I guess, started by people from Autodesk, where they started this using this inside this a simple library that I've called it as Discover. This is basically a simple JSON object that I've tried to input this data into Python, and using a framework called Discover, basically I was able to just iterate this. It does basically the same thing. This Discover framework is by Daniel Nagy, which is, I think, utilized for Autodesk optimization, which I've just taken it the exact same code piece, and I've just tried to use it in my problem. Wherein now, once you start running this, basically what it does is it kind of tries to different come up with different configurations, and each configuration, all these metrics will be like noted inside a particular um, list, wherein that list again will be optimized based on the sorting. Like if I just wanted to maximize certain letters in the area, then that will be that the case will be just taken, and then the second configuration will be built on top of that in order to deal with the next objective. So it's basically an optimization problem, and finally, what it gives is basically, if you run it over, say, let us say some 1,000 to 10,000, the number of configurations you could do is infinite, right? Like you can try with a lot of different configurations, but you can just actually set up a different threshold on which, like, you would say, I would accept this configuration with this kind of threshold, and then you can just choose like the top 10 decisions based on that particular threshold, and you could just then have your human view of deciding which configuration would be better. That's the basic way. And also the advantage of having this multi-objective algorithm put up in Python is basically it will give us the data set, and then this data set can be extremely helpful to understand the configurations, and in terms of how the performance is for across different metrics. So I'll just explain you how I did this. Basically, I've just generated some 5,000 design configurations. So this took a lot of time. Like back then, I just started it in like some my local processor. It almost took like one and a half day for me to like run this completely. And basically, I got a huge list of all these 5,000 line items, and then I just tried to analyze which configuration could be better. Now there could be a human bias. Like I could just say visually this is appealing, then that is like it's also having this high score. but actually there could be a lot of other designs which we might miss visually inspecting, right? So it's the reason why basically this metric space analysis is a very helpful tool, which wherein like you could actually come up with two different metrics at a time together, and you can add different dimensions in terms of it. This is basically a scatter plot, wherein like it would the x-axis you're taking a particular metric, on y-axis a different metric, and you could actually populate all these configurations in terms of how all these are performing. And then maybe you can just choose the optimal one, just like selecting a data point, and you can just once you hover on this, it's interactive graph. So you will get a design configuration for which the things have been optimized, right? And similarly you can try out different cases, and it's basically permutation and combination of what you want to finally take from that design. So this is something which is extremely helpful in terms of making the data driven designs. So what I've observed is basically people would come to the extent of generating all these designs, but the post analysis is not something which is being done. So having that data science background actually helped me to go further and see if what else can be done once you get this data. So the data is the key, right? Like if you have the data, then you can actually extract the most insightful meaning out of that, and which would actually help us build different, be it like different use cases, or also the most optimized one in order to drive that value. So that is something which this metric space analysis is what is capable of. And so finally, once we have all these different configurations tested on different dimensions where it fair to be, finally I could just come up with the optimized solution where it kind of satisfied all the four different metrics that I took, like in terms of maximizing the area between that and all that four stuff. And finally, I just try to make this as a workflow design, wherein like be it a simple interior setup, or all the way till like a huge design that could be implemented at a city level or at a design scale. So it's pretty simple. Like the way you can just plug it in and start with deciding what all metrics you want to optimize, and then how you design your data problem, and then finally just run this, optimize it, and analyze it. Finally, you just select some of the possible options which will be bagged with data, and also like like satisfying all the four or five objectives that you started with. So this is how it can be very advantages for any urban designer or an architect who could make utilize this as a use case.
Yeah, yeah. I really like because it's not very common. I have seen like as part of the generative design workflow, people do this kind of data visualization. At one point, I was thinking, okay, for multi-object optimization, can we do it in Octopus? And but then when you showed the how you can create JSON and then you can plug it into the JavaScript framework, I think that part might not have been possible if we go ahead with that route.
Yes, right. Uh, so the advantage of having, writing this entire from scratch is like you understand it, and you can just prepare a framework which you could utilize it for your next project, or have that, and you'll get to have that control of finite things. So Galapagos and Octopus are great. Like they will help us to initiate and conceptualize certain ideas, but in order to test and actually perform the end-to-end analysis, tools like these frameworks will actually help us. And what it does not give us is basically this final data set wherein you could just play it with different configurations and understand all that stuff. uh, and also like the generative design, the scene here in at least in India and all the different parts of the country, as we see, is basically like some of the posts that we discussed, like people just start exploring all these different high-end tools without having a practical the use cases. So this I just wanted this to people to understand this, like there's a lot practically materialistically things can be done instead of just coming up with different configurations which are like irrational. I don't say like aesthetically that may be right, and you just want to visualize it and conceptualize that, but having this data backed approach will actually help and it will actually matter to the stakeholders who are trying to invest in this particular project.
Yeah, and it's really good that you clarified parametric versus generative, because it's not like super clear to many folks that what's the key difference.
Yes. So it's unfortunate state like where we have this two different diversions of like schools of thought, like for generative design, wherein like you end up learning all these high level like Houdini, all those like simulation
True.
softwares, wherein you'll end up like coming up with different visually appealing designs, but practicality, when it comes to practicality, that doesn't help much. Like so all you can do that is like explore a lot of things and basically post some good Instagram pictures, but that is not actually helping the architecture scene and the practice that is uh, in the industry.
Yeah, that's a really good point. Like the because of the Instagram, like people wants to produce cool stuff, and I think that's where the value of this generative design tools come in. So it might be possible maybe that sometimes some kind of form enhances the aesthetic as well as the building performance, but you need like data to prove that okay, if you just do a straight regular form versus this kind of form, it's
Right.
through these results you can see it's improving performance, and that's why it makes sense.
Yes, exactly. So it's basically the same thing. Like generative design, or what as part of this exercise did is also a generative design. We try to explore different, configurations, but it has been, backed with this algorithm which kind of optimizes us for certain, measurable metrics instead of just like visually like appealing or all that, like which is rational. Also, the same thing that's happening. Like even if you look at these, right, like so all these complex forms, it is possible, but actually there's a method to these madness, or what you call it, basically trying to optimize this for a particular measurable metric versus like just exploring it visually with trying different rational stuff. So this is how it actually matters.
Yeah, like I think it's important to note uh, the factors when we do this multi-objective, and I think Ladybug provides like daylight factor,
Right.
heating load, cooling load. So that's why multi-objective is important. Like if I want like good daylight, I can just increase the amount of glazing, but then it comes with increased heating load, increased cooling. Like so, I
Yes.
think
Right.
having that holistic approach is important. That what are different disciplines and aspect will affect just from a single form change or uh, like
Right.
opening.
Yes,
Cool,
exactly.
cool stuff.
All right. So I just have another final blog that we'll be talking about. It's basically um, this is some interesting stuff like interactive maps. Basically, when we are exploring different urbanscapes and when it comes to cartography and mapping, right, it's actually very important how the data plays a vital role. So this I've been working on different projects like open source projects wherein we're trying to come up with how data can be leveraged in urban design. That is the scene and the topic that I've been like, focusing on, right? So this basic piece talks about three different open source libraries available in Python for free, which can be used to basically create these interactive maps. So firstly, interactive maps, the importance of it is basically it's you cannot even think of like how interactive visualization would help a particular business use case versus a simple a bar graph or a thing which tries to drive a certain point, right? So where an interactive will the user will actually be able to interact with that particular visualization or basically the data underlying which is actually the business, right? And then he'll be able to come up with different options, and that is again like as I told, data driven insight. So the way this basically happens is basically all you need is data again, right? So basically, we have some tools like GIS and all that, which talks about geospatial analysis. But basically, for us architect to just start with, or a urban designer just to visualize, let us say, a particular piece of a site, or a geolocation that he's focusing on for his design, what will actually help is trying to understand how all the data which is surrounding it, or which is actually impacting that particular region is distributed firstly, right? So firstly, this I start with, like, a simple tool called Altair, which is available, a Python resource. uh, so it is a simple and fast implementation with there are a lot of readily available sets which are helpful for creating simple maps. Just to start with, the Choropleth maps is basically these maps which are like tiles have been like colored of each color represent certain things, and we can actually plot this numeric features on different areas. Like for example, if you look at this map of India, which each state has been colored in a different way, like um, actually, this is a simple project that we started. Like we had a simple data set of a number of facial recognition technologies that are being installed in different states, right? So we just started with a simple data set having like each state has how many numbers. Like let us say Maharashtra has got some 10 different projects that have been plotted. So this basically kind of helps us visualize that entirely on a simple map, and as and when a person clicks on it, it would actually help. The user to get more details about. It could be either like drill down to that particular section, and there could be some subsections inside that, so that could be like visualized, or it would just give us a hover about like what is the details and the data that is talking about that particular piece. So it's just visualization, but actually it actually helps us a lot of things, explore a lot of things in terms of the geolocations. So Altair is one simple implementation that we started with, and um, so we need this geometry. We have this shape files that that are backed inside like a particular polygon, and then each polygon will have a name. Like in this case, it's a state name. So each of these state will have that polygon, and once you like pass in all this information to this basic function of Altair, it would just give out a final the implementation of the entire map. Now there are a lot of other things that can also be done in terms of like customizing it, in terms of creating some pop-ups and explaining it a lot of detail and granularity. And similarly, Plotly is another implementation where it kind of goes to the next level, where we can also interact it in a much detailed, granular way. Wherein, like, once you click on it, you can just again link what automatically, it's reactive in that nature. Wherein if you once you click on a particular plot, it will take you zoom in, and then it would actually give out some more details about that particular plot. And it's again a similar implementation, wherein like you again it's just including a shape file and just creating some base figures, adding some tiles and interactivity to that. And there's a lot of even the tiles, basically you can just customize it based on. This is basically a simple black and white tile, but you could actually get satellite images to understand, let us say, different use cases, and basic, the satellite imagery, which will actually help us understand the land use cases as well. So all that is again possible. And finally, again, another one more very important implementation is Folium. Folium is a very useful JavaScript library, which is based on like leaflet.js library, which actually gives us a lot more control in terms of plotting all these maps, and we can actually create separate pop-ups, and once you click on a particular plot, it would actually help us divert, or go into a different map itself, and see and try to understand what is happening inside that granularly. So it's basically all these three does the same thing of helping us visualize all these metrics in terms of maps. But a lot of other things are possible based on the different entities inside that. Like the way we use this is GeoJSON and TompoJSONs. And again, this shapefile is what is the backbone of this entire feature. So this just talks about the technical part of it. So what I also have is basically a simple implementation within Power BI. So This is the basic Power BI desktop that I have. So I'm just talking about the workflow that I do. Like basically, this is a sample data set, but when I get get hold of a simple data set that can actually be inserted into this Power BI as a table inside this, and then that could be used for visualizing different things. So in this case, I'm just using a Mapbox visualization inside Power BI, wherein I have a simple data set. I'll just show you how this looks. So this is how it looks. Basically, it just is a list of all the districts that we have as part of India, and there are different attributes of that particular thing, like what is the literacy rate, sex ratio, area, population density, working population rate. So these are different metrics of that particular district, and this is as simple as that. Like we just have a location and then its attributes. So it's pretty simple and powerful to actually visualize this inside the map, which actually helps us understand. Like visually looking at a table will actually not give you anything, right? But when you visualize this in terms of a two-dimensional map or even 3D, basically what it gives us is this sense of understanding of all the configurations. Just think of it, this is just an implementation at a country level, but think of it just as a city level implementation, where that could actually help us understand the impediments in city, the things that could actually affect our designs of particular site. So in that way, it's actually helpful. And one more aspect of using this Power BI is leveraging this functionality of you know these filters that could actually work. So if you look at here, so this is talking about different filters, wherein I'm just filtering this based on, let us say I just want to look at the districts, all the districts where the working population rate, let us say, is starting from 25 to all the way till 56%, right? So now if you look at, there's a lot of lot more districts that have been shortlisted here, highlighted, and you can actually get into details of it. Like if you click on a particular thing, it actually speaks about that particular area and what all things that that attribute has got. So it gives us a sense of understanding that visually and spatially, how where all these things are playing, and which part of the geolocation that we are targeting at is feasible, or the maximally working for us in terms of the metric. And uh, it also talks about a lot of other things, like where things could be improved in terms of, like when we are looking at a lot of things, like which can be applied in real world cases, that would actually help us understand these different aspects of a particular geolocation. So yeah, this is a sample just project, just wanted for explaining how the workflow could be. But a lot of things can be possible. Like even I could just bring in a complete my plot into this and try to understand different attributes and try to play with different filters in order to come up with a optimum design solutions and strategy.
I see. And I think this was quite insightful, and it's great to like see through the interface. Uh, I'm curious. So Mapbox, when you import it, it has attributes. So for the table, did you like download another database and then link that database with Mapbox?
Um, okay, so the way it works is basically Mapbox will have something called tile sets by default. So let me
Mm-hmm.
just open that quickly. Uh, okay, so there's something called tile sets, wherein like you can just import your existing shape files, or you can just get it from Mapbox. It's OpenStreetMap. So what it does is basically it will give you details about, like basically it is a shape file. And then once you have this in as a tile set in your Mapbox, what it would generate is a key, a layer key, which can then be imported inside your Power BI. Here, if you actually select this Mapbox visualization, there's an option inside your visualization settings. You could just put your access token key first as an authentication, and then there's something called Mapbox API URL, where you can just put your tile set key there, so you can just get your data imported. It's all in cloud, right? So that's the way you just get it from that Mapbox.
Oh, I see. So in Power BI, you call the Mapbox API. It has all the
Yes.
data which is hosted on cloud and okay.
Right. It's not necessarily hosted on Node. Like basically, this table that I have, it's a local table that I have. The only tile set is basically coming from the cloud from the Mapbox. So if you want to say, let us say, I wanted to add a particular attribute here. Let us say for each district, I have some data with me locally of what is the, let us say, um, literacy or something like literacy rate of. I just wanted to add a new column, which is possible, right? Then directly that can be like in real time it would actually start showing up here in terms of that attribute for a particular piece.
Yes. Yeah, I think Mapbox is a really useful tool. I came across it like last semester, and a lot of visualization could be done. And it because of the API, it's so easy that I can easily like create a website and host it on the website to showcase all the visualizations.
There's a
So
lot
if
of
I
other
were
functionalities as well, like it enables us to come up with all these different maps like geocoder, heat maps, clusters, choropleths, which is what I did here. It's basic coloring of all these and raster tiles. So all of these functionalities they have just Mapbox is basically the implementation on cloud is so vast, but all of them they have tried to build, kind of get it into this Power BI implementation as well, which is actually great. Like we can, I've seen actually a lot of analysis being done in terms of site planning when it comes to this. So I'm actually trying to get started on that. I'm trying to explore still like there's a lot of visualizations that can actually help the planning of particular piece in terms of architecture or urban design as well. So uh, it's great tool to explore.
yeah, Srihari, I have a question. So for example, if in Mapbox website I can play with the layers, opacity, color, data, why should one import that in Power BI?
Right. So it's basically Power BI will actually have a lot of other things as well. Like let us say if you have your database, right? Like you are dealing with certain use cases, and then you want some kind of geospatial analysis to be plugged into your thing. So that is where it kind of helps us a lot. Like basically by native filtering and all that, the Power BI is extremely powerful in terms of manipulating data and trying to create this interactive stuff. Let us say if you just want to, you're doing on an urban design project and you have a lot of data that you've already been working with. So Power BI is a tool for that. Like the Mapbox implementation can actually complement that, and you could get more insights in terms of let us say environmental aspects of it or anything that has to do with maps, right? So that it acts like a plugin or a complement for your existing analysis. So even otherwise, you can just explore this within Power BI in order to leverage all these tools of the filtering and all that. It's all interactive. And another good thing with Power BI is basically once you have a proper license, you can just actually publish different reports and share it across different stakeholders. It's like a business intelligence tool. So that is the advantage of Power BI integration with Power BI.
Is it, and when you say report, like does it like producing charts or graphics from the map?
Yes. So Power BI reports are essentially basic sheets or dashboards, as we could call. Basically, it's interactive, right? Like if you publish this entire sheet and like share it with a different stakeholder who's like responsible or like interested in this data, so he also gets to do this interaction. Like maybe he can just adjust this and basically this entire design as a report can also be documented and shared with them so that they could utilize this and try to get the insights directly on like on hands-on insights instead of like a simple a report which would say that we have found that this is what it is and all that. It's a instead of basic a PPT or a presentation. This is an interactive next level of report wherein you can just let the end user also interact with your reports.
See, like so it gives much more flexibility to end user in terms of dashboard interactivity and experiment just
Yes,
explore. I see.
right, exactly.
And any other like things you have seen use cases where either in geospatial analysis or BIM people have integrated Power BI?
Uh, yeah, there's a lot of things happening. Like Power BI, like initially that I've introduced to this going down. Basically, they have a lot of use cases like be it like Rhino Revit integration. This is again a very useful integration that kind of helps us to get the BIM, the part of Revit integrated into Rhino, wherein you can just use like these scripts and parameter design to actually iterate different designs. And once that entire design is conceptualized, then you can just bring it to Power BI and try to play with a lot of things in terms of understanding it, and even for us to as a present it to our clients or the stakeholders. This will be extremely useful. So this is one aspect, and apart from that, a lot of things are happening in terms of geospatial analysis. Uh, like we've seen, the previous podcast I've been watching, like a lot of things in terms of um, these apart from these APIs that I have talked about in this use case, where it's just like a basic plotly and folium. There's also a lot of things are happening in terms of using machine learning on these plot geospatial analysis part. So I'm yet to try on those things, but yeah, a lot of things are happening in terms of the data being backed in terms of urban design and all these things. It's exciting times to be in, and like a lot of things to explore. But yeah, I think slowly in India this penetration is getting slightly the traction, and I'm hoping that a lot of people will come up and leverage these tools to kind of build different things which actually matter.
Yeah, I really hope like more and more people get aware and start deploying it, and also there is some mechanism of like people teaching or training the
Yes,
the newer generation. So
right.
uh, I wanted to ask is like based on your experience, we covered Mapbox, we covered Plotly, Folium. What are some tools, libraries one should be aware of if they want to do data science or architecture or urban planning?
Yes, that's a good question. So basically, a lot of people just approached me saying that how are these things even possible, like being like an architect who's not even introduced to basic coding, like unlike engineers, right? So it's I feel it's actually very important to understand the programming is an essential skill, like be it for architects or any creative person, right? Like so I would suggest Python. Definitely one needs to understand the basic concepts, and then there are a lot of libraries that are Python being like a very high level language. It's pretty simple to implement a lot of these implementations without actually getting your hands on into these scratch building from scratch all these implementations. It's pretty simple. So Python is basically a prerequisite for any person to get into this and trying to explore data, be it data science or analysis or anything. And then uh, to be able to like load the data, pandas is one library which actually helps us do that. Like it's basic data science one of the ones, right? Extract like a certain part of a table. That is something as a prerequisite a person needs to know. And apart from that, a lot of these things like they kind of explored here. Like if one is interested in geospatial analysis, you can just look into these three different libraries: Altair, Plotly, and Folium. Apart from this, a lot of simple visualizations like Matplotlib and other things. But basically, these are prerequisites, and uh, these are kind of good to have knowledge on. Basically, if you try to explore, but Python, basically, once you start exploring Python, there's a lot of things that try to will be opening up, and it's kind of takes you through that journey of exploring different things by default.
Yeah, that's a really good piece of advice. And I, what from my experience, I think once you start going deeper into the Python, you'll find like programming is so efficient. Like people have developed libraries, so you don't need to write the same function from scratch. So, and a lot of
Yes.
additional functionality can be added. So it's it will open one's wings that okay, I could do this in JavaScript, I could do this in Python, and animation, with database.
Yes, exactly. uh, and also the age that we are in, basically, creating these apps and starting your own stuff, it's as easy as it could be. Like it was never this easy. And there are a lot of tools that you can just leverage and get started without thinking about how to implement it. And that is the exciting times that we are currently in. I just hope like people will start leveraging this in a good way, and the try to improve the architecture scene here in this country and globally as well.
Yeah. And like in India, if someone is interested to learn, like where can one find community or those experts or like-minded people who are doing data science in architecture or
Um, yeah, I've been trying to find that. I as it were, it's a comparatively a new and a rare kind of scenario wherein an architect would look into these different aspects of data science. But I guess like the community who's actually interested in technology basically will need some orientation towards what exactly needs to be done. Uh, as I told, like this is different trend of being and technology being used for just generating these aesthetic designs which are not like essentially useful. So there needs to be this revolution that need to bring. And I am actually very glad that you're trying to do something very similar, like you and as well as some of the folks who you started creating this kind of content and trying to explore all these trying to create podcasts from different technologies and people in architects and all that. uh, I think that is where we need to focus more and trying to impart this information and knowledge, so that we kind of create this community and start working towards all these useful technologies.
yeah, like I think there are very like few people I have seen who are trying to like share knowledge. Digital future is also a good one. And the thing I feel bad is like even I knew about AI, but I didn't experiment it because like in civil engineering or architecture workflow there was not a point that okay you can't solve this task without AI. But once I experimented it, once I looked into what are the possibilities with data science, thought, oh my god, there's so much stuff which you could improve in the AEC productivity or development which we haven't explored. And that's why like I think once we develop simple interfaces or share more and more knowledge, people will get more aware and start getting into it. Because to learn it, knowledge is everywhere in YouTube about like machine learning or AI course, but it's the translation of how AI can change architecture or construction that that experience or awareness is missing. So that's why I interview a lot of people who are doing some cutting edge work.
Right, exactly. Also, the way it happens is there are two aspects to it. Like one is solving the existing use cases of trying to optimize and improve the different processes that we've already been following, which actually the digitization or like basically digital transformation of these industries would actually help. But the what AI and ML brings to the table is basically the different scenarios which are untapped yet. Like it will expose us to these different possibilities which otherwise we would not think of it. Like we do not even know that something of this sort is possible unless we try to explore this. So it's actually important to come out of this entire thing and look at objectively and try to understand what is happening in tech space, like different industries like finance and all that. um, Especially with the kind of startups and the age that we are in, especially the economy that uh, uh, kind of revolutionized everything, right? So it's actually important for even our community to build this thing up and try to revolutionize the entire thing, that the way the conventional architecture is being practiced inside be it India or world, right?
Okay. And like I didn't study architecture in India. Like I did it for my master's. So I don't know like what will be the best way to get it out among students or young community. Because I one of my friends said like they have like organized NASA, which is an architectural fest. I see a lot of like Indian architecture students learning new software or getting into computational design. So it's not that they are not like they want to learn software, but if we can like start introducing this AI or data science based workshop along with those computational workshops, I think that could be a good start.
Yeah, I agree. I agree. Yeah, I do agree that these inventions of NASA and a lot of other things that happen, which like people, especially architecture students, are very interested. Even I was part of a lot of these competitions as part of my graduation. Uh, that is one aspect of it is like the personal interest from a particular person, but also what is actually needed in the industry is like encouragement in terms of the practicality of it, right? Like once a person, let us say, he kind of tries to learn everything in AI, he has some ideas, but what does he do once he comes out of that? Like, is there any support in terms of implementation, starting up, and all that? So that is something which needs to change, wherein like we need to come up with different startups who and only then like backed by different different persons in the industry in terms of economy and finance. uh, that is what is going to bring that revolution of and then slowly these clients will also start understanding the importance of these data driven and how that could actually impact their lives in terms of the decisions that they make for going with AI based models and all that. So it is a long process, and slowly that adaptation, I'm hopeful, will happen. And this is happening in global level. At least it would take some time, at least in India, to happen. That, but yeah, meanwhile that happens, I think students and basically academia should focus on these cutting edge technologies to prepare the architects. The conventional style is almost like obsolete now. Like it doesn't add any, the details like be it like a diploma student or a conventional civil engineer graduate will be able to do everything that academics will essentially do if they don't kind of leverage this technology.
Nice. And I think you raised a really good point because uh, from my experience, like the budget is tight in an architecture or in general firm. So if they want to have people doing R&D in AI, it's generally not feasible. Like for unless the company is very big and they have good funding. So two
Yes.
things is like even if someone learns what is the deployment or end use case, and I think a lot of people are currently working and they are finding integration of ML use cases. So once like in States and in Europe, I have seen like few startups doing it. And I think maybe a startup is a good way because it might be depending on how you do fundraising. If the idea is strong, and if you can convince
Yes.
the investor, you could buy some time to do more research and develop those tools. And once that goes into like media or client, then they'll start apply to more project and even architecture firm can do subscribe to that software. So
Yes.
I think
Exactly.
you're right. Like in that pathway might be more feasible.
Right. I agree.
Hmm. But yes, students have time to learn this because like they're not using companies R&D. So I yeah, let's see if there are any student organization or any fest would, who are willing to do this kind of AI in design workshop.
Yes. So that will be a good start. Also, we need to basically inculcate this habit of exploring what is happening outside the industry, right? Like, if you look at these all these external say industries of fintech or commercial real estate technologies, wherein they would just like come up with a different idea and they would iterate it and they would be selling product like each any person, if you look at in the industry, will have two or three startup ideas and they'll be constantly hustling in terms of finding these. So that is something which the culture is something which I think needs to be inculcated in the space here in architecture and civil engineering as well. So that is what would make a difference.
Yeah, dude. Like one of the reason I had to come to you is because I couldn't do masters in architecture in India. Like the multidisciplinary thing is so
Yeah,
crucial, and I always be get more aware when like architects or AC folks say about technological innovation, because many times the thing which they say about innovation is like AR, VR, or some tech products from gaming industry or other industry, which is just adopted and integrated. And because you have like capital, could buy that
yeah,
and integrate and sell it to the client. They're doing this differently. But even for aerospace industry, we bought that software and Frank Gehry used it. So innovation is honestly it's very rare. I have seen in AEC. It's integration is a lot.
yeah, exactly. All these game engines and fancy stuff. It's just they're trying to integrate it, and there's hardly any innovation happening. Uh, Also, that there's a huge time lag, like the time where these Unity engines are trying to be adopted in the, let us say, gaming industry. It's actually 10 years after that is what the architecture industry is trying to adopt that. So by the time it's already too late and obsolete.
They have something new. but
Yeah,
but I think it's slowly it's becoming better where we are integrating those. But I think the point which you made is which is important is looking at a lot of other industries and finding like what thing they are doing very well. Can we integrate it or take some part of it that in our workflow to make it at least some percent better.
yeah, I agree.
Nice. So we covered a lot of things. It's
Yes.
already over 1 hour mark. Is there anything which we didn't discuss or any last thoughts you want to share?
Uh, yeah, I think we've discussed a lot of things. So this is just an attempt I've been trying since the past 2.5 years. So to trying to get into the tapping these technology aspects of what can be utilized and how we can leverage this tools of data and artificial intelligence. So I just hope this a lot of people might get this inspiration of trying to do this as part of their exploration in terms of design or even post design. And a lot of things are still possible. What I've covered is just like scratching the surface, not even like a 1% of what is actually possible, right? So what is important according to me is having that knowledge of what else is achievable and what impact does it bring to the table, like once you implement this, right? That is where you will be able to kind of go to the client or who's a stakeholder and let him know that this is what you need to do in order to get this leverage. So until and unless then there'll not be an encouragement from the beta stakeholders or the client side who's investing money into building all these projects. So I think that is what is important, and I'm hoping with all this kind of education that is happening and all these people, especially people like you who are trying to educate a lot of individuals through these podcasts and different documentations. I hope that this will kind of will progress towards the right direction, and we'll see some good change in the coming years.
Yeah, dude. Like, and like, thanks to you, like, who is open to sharing their knowledge and stuff, because then people are scattered in, in few places of in India who have expertise. It's like collecting them, sharing them, forming a small community, and we need to take one step at a time. So even if like we're sharing content at least maybe 5 years or 10 years, people will realize, and then suddenly they will jump. So let's see.
Yes, I'm hopeful. Right.
Yeah. All right. It was a fun discussion. Thanks a lot, Srihari, for your time to do this. And hopefully, we can plan on something. If there is some workshop we could do in India, like I'm open to just meet people and also give a small presentation. Because if
Sure.
even if people start working on theses related to AI or data science, they'll get more and more knowledge.
Yes, I agree. Yes, thank you, Mayur, for this, and I hope like we'll have this collaboration, and we'll see what else can be done in this, and let's see like what else can be explored in terms of the architecture scene that is currently in India. Thanks for having me.
Thanks a lot. Have a nice rest of